In this lesson, we're going to be talking about literal equations. By the end of this lesson, you should be able to solve for a specific variable when you're given a formula or an equation, and use formulas to solve real-world problems. A literal equation is an equation where you're not solving for a specific numerical answer, but instead you're going to be solving or manipulating the equation for a particular variable. We see this a lot when we look at formulas. Formulas are examples of literal equations. These are equations that have more than one variable, and they're used to solve for a missing amount. Now, being able to solve a literal equation is going to be really important when we're dealing with formulas because you may not be missing the amount that the equation is set up for, such as energy equals mc squared. We might not be missing the energy. What we might be missing is the mass. And so we want to be able to manipulate that equation so that we're solving for the mass instead of for the energy. Where we commonly see this is in the distance equation. The distance equation is distance equals rate times time, or rate multiplied by time. It's this d equals r equals rt. But again, I might not be missing the distance. I might have the distance and I might have the time, and instead I need the rate. So we can manipulate this equation so that we're solving for the rate instead of solving for the distance. And the same thing would be true for the time. When we're solving a literal equation, when we're solving for a variable, remember our steps for solving equations is our goal is to isolate the variable, and so we're undoing all of these operations. Remember that we're doing the reverse of PEMDAS, so we take care of addition and subtraction first, then we move on to multiplication and division, then we undo parentheses if there's parentheses, and then we undo exponents, and then we do parentheses last. We take care of parentheses at the end. So let's look at an example. So if we look at example 1, in this example we have the equation negative 5x plus 3y is equal to negative 15. And part A wants us to solve this equation for y. So we're going to manipulate this equation so that instead of negative 15 being by itself, we have y by itself. So this means that we need to get rid of everything that is not this y right here. So the first thing we're going to get rid of is this negative 5x. To get rid of a negative 5x, we're going to add it to both sides. So add 5x to both sides. Now, I can't combine the negative 15 and the 5x because if you recall, these are not like terms. Like terms have the same variable to the same power, and 15 and 5x do not have the same variable. So we're going to end up with 3y is equal to 5x minus 15. Notice that I've written the variable in front. It's good algebra to put the variable part in front and to put the constant at the end. And then our last step is to get rid of this coefficient that's in front of the y. And so we're going to divide everything by 3. 3's are going to go away here. And we're going to end up with y is equal to 5 over 3x. We're just going to leave it as 5 over 3. We want an exact answer, and 5 over 3 will give us a repeating decimal, and we can't write that repeating decimal out. 15 divided by 3 is minus 5. And so for solving this equation for y, the equation is y equals 5 over 3x minus 5. Now, we're looking at solving it for x. You're doing the same thing. So this time, instead of moving everything away from the y, we want to move everything away from the x. So we have our equation, negative 5x plus 3y is equal to negative 15. Now we're moving everything that's not the x to the other side. So we start by getting rid of this plus 3y. So we'll have negative 5x. Remember that 15 and negative 3y are not like terms, so we'll just have negative 3y minus 15. We divide everything by negative 5. The 5's go away here. Negative 3 divided by negative 5 it's just going to be 3/5. The negatives are going to go away because the negative divided by negative is a positive. We leave our fraction because we want that exact answer. Minus, or actually not minus, negative 15 divided by negative 5 would be positive 3. So our equation here would be x is equal to 3 over 5x, or 3 over 5y plus 3. Let's look at another example. So in example 2, we have p is equal to a times b plus c. And we want to solve this equation for a. So this one's pretty easy. We want to look at, again, moving everything that's not the a to the other side. So remember that we typically do parentheses last, but because both of these terms are inside the parentheses and the whole thing is being multiplied to a, what we're going to do is we're just going to divide everything by this parentheses that's right here. We're going to look at this as one, we're going to look at this b plus c as one singular item. So we divide both sides by b plus c. The b plus c's go away. Same thing on the top, same thing on the bottom. They cancel out. And what we're going to have is b, or p, over b plus c is equal to a. We can't simplify any further from that. This would be our equation. If we want to solve for b, we're going to have to do a little bit more on this one. Again, we're following reverse order of operations. So there is no adding and subtracting on the outside. We do have multiplication. So we're going to have to get rid of this multiplication of a first before we can do anything inside this parenthesis. So we divide both sides by a. That's going to get rid of the a's here. So now we have p divided by a is equal to b plus c. Now remember, we're solving for b, so I still need to get rid of the c. We're going to subtract it from both sides. And what we're going to end up with is p over a minus c is equal to b. And this would be our equation for the second one. Looking at 3, we have a formula. We have the formula for a right circular cone. The formula for this right circular cone is S equals, or surface area equals, pi times radius divided by, or times the slant height plus pi r squared. We want to solve for the slant height, or also known as the lateral height. So we need to solve for this L. So S equals pi RL plus pi r squared. We're doing reverse order of operations. So we need to get everything that's not the L to the other side. So anything that's not this L needs to move. The first thing that we want to move is this pi r squared, because it's being added and subtracted. So we want to move that to the other side first, because we undo adding anything that's being added or subtracted to the variable first. So we're subtracting this pi r squared from both sides. Forms a zero pair here, so it goes away. And here we're going to have s minus pi times radius squared is equal to pi r and L. Now, we have multiplication happening throughout here. We have pi times r times L. Again, anything that's not the L we want to get rid of. Since both of these things are being multiplied, to undo that we would divide. So we're going to divide both sides by pi and r. So let me change this for a second. Let's do this, pi r. The L stays here. That's the only thing that's left on this side now. The pi's cancel out. We have two r's on the top. This is what this r squared is. We have one r on the bottom, so the one r on the top cancels out with one of the r's, or the one r on the bottom cancels out with one of the r's on the top. And so for this part, we just have r, because the pi's also went away. And s over pi r, because we can't cancel anything out on that side right there. Looking at example number 4, we have 5 more than a number is 6 less than twice a number y. So we have 5 more than a number x. So 5 more than a number x is, here's our equal sign, is 6 less than twice a number y. So 6 less than, this says consider the twice a number y first and take 6 away from that. So here is our equation. We have 2 variables here and it wants us to solve for x. So in solving for x, what we would do is subtract the 5 from both sides. X is now by itself, and we have 2y minus 11. Here we have like terms, we can combine the constants here, and so x equals 2y minus 11. This is our literal equation. Before moving on to the next video, please consider the following statement. Solving a literal equation means, what does it want you to do? All right, as usual, please subscribe to this channel so that you get updates on videos as they are released.